At a depth where sunlight has vanished, one of the worst survival strategies seems to be turning on a light. Yet the deep ocean is crowded with animals that flash, pulse, sparkle, and beam. In a place built for hiding, being visible can mean the difference between eating and being eaten. So why has darkness produced what may be the largest light show on Earth? To answer that, first imagine sinking below the familiar blue surface. Red sunlight disappears quickly, then orange and yellow, while blue travels farthest through seawater. By roughly 1,000 meters, even the last traces of daylight are gone. Below is a world without sunrise, moonlight, or seasons of brightness. But it is not a world without light. Most of the light down there is made by life itself. A study based on more than 350,000 observations found that about 76% of open ocean animals observed were capable of bioluminescence. Among jellyfish and their relatives, the share was even higher. The exact percentage changes with habitat, depth, and what scientists can identify, especially near the seafloor. Still, the pattern is unmistakable. In the open deep ocean, glowing is ordinary. Bioluminescence begins with chemistry, not electricity. A light-producing molecule called luciferin reacts with oxygen, often helped by an enzyme called luciferase. The reaction releases energy as visible light, and the animal controls when and where it happens. Some species manufacture the ingredients themselves. Others obtain a key ingredient from food or house-glowing bacteria inside a specialized organ. Because different creatures use different chemicals and body structures, bioluminescence appears to have evolved independently many times. Most marine bioluminescence is blue or blue-green. That is not an artistic choice. Those wavelengths travel especially well through seawater. Many deep-sea eyes are also tuned to detect them, making a tiny flash useful across surprising distances. Red light usually disappears before reaching the deep, so red animals can look nearly black. But a few dragonfish produce and detect red light, creating something close to a private search lamp that many prey cannot see. Light can reveal a hunter, but it can also erase one. During the day, faint sunlight still filters into the twilight zone from above. A fish or squid viewed from below should appear as a dark silhouette against that dim ceiling. Rows of photophores on its belly can match the color and brightness overhead. The animal does not become brighter. It cancels its own shadow through counter-illumination. Other lights are meant to be noticed. An anglerfish suspends a glowing lure near its mouth, turning curiosity into a trap. Some dragonfish carry luminous barbels, while certain fish use light organs like small headlights to search nearby water. In an environment where meals may be separated by long stretches of emptiness, a single controlled spark can bring food within striking distance. But every light has an audience, and the wrong observer can be deadly. So many animals use bioluminescence as a weapon of escape. A sudden flash may startle a predator long enough for its target to vanish. A deep-sea shrimp can eject a glowing cloud, leaving a bright decoy where its body used to be. Some worms release luminous packets like disposable flares. One squid can even shed glowing arm tips that cling to an attacker while the squid retreats into darkness. Then there is the most devious defense, the burglar alarm. When an Atala jellyfish is grabbed, blue light can race around its bell in a spinning display. The signal may attract a larger predator, not to rescue the jellyfish deliberately, but to attack whatever is holding it. The original hunter suddenly risks becoming prey. In the deep ocean, calling attention to a fight can be a way to escape it. Light also solves a quieter problem, finding the right partner in an enormous three-dimensional wilderness. Patterns, positions, colors, and timing can act like species-specific signals. A brief sequence may say, in effect, correct species, correct condition, and close enough to meet. That matters when wasting energy on the wrong animal could mean missing the only mating chance for days or weeks. Seen this way, the deep ocean is not simply dark, it is filled with coded messages. That changes the central mystery. Deep-sea animals do not glow despite the darkness. They glow because darkness makes every photon more valuable. A lure, disguise, warning, decoy, search beam, or signal. And the darkness also makes this world difficult for humans to observe. Traditional submersibles arrive with bright white lamps and noisy thrusters, which can scare away light-sensitive animals or alter their behavior. Low-light systems, such as the Medusa, were designed to watch more quietly, using far-red illumination that most deep-sea animals do not detect. Its electronic jellyfish imitates the spinning burglar alarm display of Atolia. During one deployment off Japan, that artificial signal helped bring a giant squid into camera range. The discovery was a reminder that bioluminescence is not decoration placed on deep-sea life. It is part of the ocean's operating system, shaping who finds food, who disappears, who communicates, and who survives. The deepest ocean looks black to us only because we are not fluent in its light.